So, what if your phone wasn't just a tool for running apps, but was actually aware? Aware of the world around it? Today we're going to explore a really fascinating vision for technology that's way beyond just smart. We're talking about tech that might actually feel, well, alive.
And this quote, it really gets to the heart of it. We're not talking about just another spec bump, a faster processor or a slightly better camera. No, the vision here is a complete, fundamental shift in how we relate to our devices, moving them from just being tools we order around to becoming something that perceives the world and maybe even resonates with us.
Okay, so what does a future like that actually feel like? What kind of products could you hold in your hand or wear on your face? Let's take a look at a few examples of what this new kind of living AI could make a reality.
All right, first up, picture an iPhone S. Now, on the outside, it looks pretty familiar, but on the inside, it has a completely new sense. It can literally smell. The idea is that it could perform something called digital olfactory mapping, which is a fancy way of saying it can interpret all the tiny molecular cues in the air around you.
Then there are Apple Glasses, and no, we're not just talking about getting your notifications beamed into your eyeballs. These would work hand in hand with your phone, using that same deep intelligence to overlay a reality with genuinely useful AI-driven context. They wouldn't just see a tree, they'd understand it on a much deeper physical level.
And here's where it all starts to click together into a real ecosystem. Imagine a device called the HomePod Lung. It's not just a speaker, it would be actively managing your environment, modulating the sound, the scent, and even the quality of the air you breathe, all to improve your well-being. It's about creating a truly responsive, healthy space.
Okay, pause. I know what you're thinking right now. A phone that can smell? This is starting to sound a little like science fiction, right? But believe it or not, there's a really detailed technological vision behind all this. So let's peel back the layers and ask, how on earth is any of this possible?
Well, the answer starts deep down, at the silicon level. We're not talking about just a faster CPU or a beefier GPU. This whole idea hinges on a completely new kind of processor, something called the V-chip. And this chip, it's the heart of everything we're talking about today.
Now you see this is described as a 2-nanometer cognitive coprocessor. The 2-nanometer part just means the components are incredibly tiny, making the chip super dense and powerful. But that's not the real story. The keywords here are perceptual cortex and cognitive organ. See, the V-chip's main job isn't to make your games run faster. Its job is to give the device the ability to actually perceive and understand the world around it in real time.
And this really makes the difference crystal clear. Think about it. A CPU or GPU, its job is to execute coded instructions. You tap an icon, it runs the app. Simple. But the V-chip, its job is to run awareness. That is a massive shift, right? We're going from a machine that just reacts to our commands to one that is genuinely perceptive.
So how exactly does a chip run awareness? Well, the key seems to be a system of what are called tokens. Instead of just crunching raw data from a sensor, the V-chip thinks in these neat, compact packets of information. You've got ReSO tokens that encode the actual physics of the environment, things like electromagnetic fields and motion. Then you have screen tokens that summarize what's happening on your screen. And finally, anim tokens, which use all that info to predict things, creating a super fluid, almost living UI.
All right, so for a device to be truly aware, it needs senses, right? And the first sense we're going to tackle, the one powered by this V-chip, is a complete reimagining of what it even means for a machine to see something.
Right now, computer vision is all about pixels. It looks at a photo, sees a bunch of colored dots arranged in a certain pattern, and says, yep, that's a bird. It's pattern recognition. But this concept, digital electromagnetic mapping, or DEM, it's totally different. It's about perceiving the full electromagnetic spectrum. It wouldn't just see a bird's shape, it would see the underlying physics of the bird, its heat signature, the way its feathers reflect UV light, everything. So, instead of the AI just storing a JPG of that bird, it creates something called a spectral object card. You can think of it like a rich physical profile for that object, a model of how it interacts with energy across the whole spectrum. And that's the crucial part. The AI's understanding is now grounded in real-world physics, not just a flat collection of pixels. Okay, so the device can now see the world in this totally new, physics-based way. But let's get back to that other sense we mentioned earlier. The one that sounds kind of impossible for a smartphone. This is where digital olfactory mapping, or DOM for short, comes into play. The whole idea is to give the device a sense of smell by letting it detect and interpret chemical signals in the air.
Specifically, it's looking for things called volatile organic compounds, or VOCs. Those are just the tiny particles that create all the smells we recognize, like fresh coffee brewing or flowers in a garden. So how would this actually work in practice? Well, it's broken down into 4 main steps. First, a tiny micro pump pulls in a little sample of air. Second, that sample hits a special sensor array that analyzes its chemical makeup, looking for those VOCs. Third, that unique chemical fingerprint gets turned into a compact olfactory token. And then, here's the magic part. The V-chip takes that smell token and fuses it with all the other sensory data it has, like what it's seeing, to build a really rich contextual picture of what's happening.
Okay, so let's recap. We've got a device with brand new Sensus. It can see physics, not just pixels. It can literally smell the air. You can't just slap a normal operating system on top of that and call it a day, right? You need a whole new foundation, an OS that's built from the ground up to handle a device that's this aware.
And at the very heart of this new global AI OS is a concept called templates. Now, don't think of these like the rigid apps we have today. Think of them more like flexible Lego kits for any possible action. The OS would use these little modular blueprints to build whatever you need on the fly. So instead of you having to find and open your coffee app, you just say, "I want a latte," and the OS would instantly pull together the perfect template to make that happen.
This whole thing is designed to work across 3 layers. First, you've got the device layer. That's the AI running right there on your phone, handling all the immediate, private stuff. Way up top, you have the provider cloud layer, where all the heavy-duty computation and the master library of templates live. And in the middle, you have this critical orchestration layer. Think of it like a super smart traffic cop, constantly figuring out which template is the absolute best one for what you're trying to do at any given second.
All right, let's just step back and look at the big picture for a second. We're talking about a perceptual chip, brand new senses grounded in physics, and a totally new AI-first operating system. When you put all that together, it's pretty clear this isn't just another incremental update. This is a blueprint for a giant leap into a whole new category of technology.
In this quote, it just says it all, doesn't it? The whole point is to transform the iPhone or any device from a reactive computer that just sits there waiting for you to tap on it into a perceptive being, something that actually understands its environment and can coexist with us in a way that feels, well, way more natural and intuitive.
And that really leaves us with a pretty profound question to think about. If our technology could sense the world with the same physical richness that we do, if it could perceive light and motion and even chemistry, how would that change everything? What happens when the technology in our hands doesn't just respond to us, but actually breathes with us,